All right, I'm just going to give you a quick reminder on how to do today's assignment. I taught this to you before, but I just want to make sure that you guys don't go into it like, oh, I forgot how to do this. So we'll do just, you don't have to write this down, but you can. You've already taken notes over this, so it's completely up to you. But we're going to head in now to quadratics, factoring quadratic trinomials. So before we can factor, we have to be really, really good at multiplying. Like factoring is the backwards of multiplying. So we're going to spend a day, at least one day, we'll see, and practice with today's assignment number 19, on how to multiply binomials together. So again, you've already got notes on this, but I'm definitely going to at least record this so that it's out there. So today's the 20th. Tomorrow is my birthday. Today is my last day of not being 50. How's that? I should do something. I should go running or something. Go lift something. Go climb some stairs. Do something that an old person doesn't do. Huh? Go, boy, go parachuting? Whew. That's rich. Bungee, I've been there, done that, never doing that again. That could, now, yeah, well, it sounds fun. Yeah. You go bungee jumping and you let me know how much fun it was. Uh, yeah. So just a recap on multiplying binomials. So I'm going to do 3 examples like on purpose, like scripted in, like they have a specific intention kind of examples. But if you feel like, oh, I could use a little more, let me know. So first off, here's an example of a binomial. And here is another binomial. And our job is to multiply them together. So remember to put your cursed cell phones away, like all the way away off your desk, so you're not even tempted to swipe and tap and respond and like and all that nonsense that you guys do. Yeah, so anyone remember how to do this? Yeah, nice clean way to say it. You distribute each thing from the first binomial into the second. So I think the way I explained this to you the first time was like 3x is kind of like a worker bee, right? And remember that he's got 2 jobs to do. So we're going to multiply the 3x to here. And what do we get? 15x. Nice job. Perfect. 15x squared. And then we're going to multiply the 3x all the way across to here. So 3x is still working at this point. And what is 3x times positive 5? Good. So we're going to always put in signs. Remember, always insert, after the first term, always insert a plus or a minus before the term that you put in. So we're going to put in plus 15x. Right? And now it's negative 4's turn to go. And so negative 4 is the worker whose turn it is, and he's going to multiply by the 5x. And what do we get? Negative 20x, good. And then negative 4, still working, is going to multiply by 5. And what do we get? Minus 20, good. And then we're going to combine like terms, and that'll be that. And you will reach a point where you start to actually do these in your head. It won't happen like straight away, but it will. Before this assignment's done, I'm guessing, but don't feel like you have to. But if you start to feel like I can do these faster, do them faster. It's okay. So we're going to wind up for a final answer with 15x squared. And how many x's will we have in the center? Yeah, so minus 5x, and then bringing up the rear is minus 20. So that's just a real generic sort of binomial times binomial. Now, there are 2 what we call special cases. And in these problems, we approach them generally about the same way, but sort of unique things occur. So the first one is something like this. Have we seen these? Right. And so there's a quicker way to do this. Have you heard me say square, square, multiply, double? Has that come out of my mouth yet in this class? Yeah. Nice, nice, safe way to do this is to remember, what does it mean to square something? Well, what it means to square something is to multiply it by itself. And so as we're first learning this, it's best if we just acknowledge it as what it is, and that is 4x minus 1 times another perfect copy of 4x minus 1. And again, the approach is repetitive multiplication, like Bryce said, distribution. And so here we go. What's 4x times 4x? 16x squared. And what is 4x all the way across times negative 1? Right. And then what is negative 1 times 4x? Right. And then what is, for the capper, negative 1 times negative 1? Right. I mean, there's nothing in this. There's very little meat on this bone. There's very little reason for anyone to miss these. It's pretty basic stuff. And then when we see the ending, we get 16x squared. And how many x's? Negative 8x or minus 8x, and then plus 1. And what's unique in a conversation that we'll have more further down the line is the fact that these two terms are always going to be the same in problems like this, which is, again, I don't really want to go down that road today. I don't want to confuse anybody, but that becomes very important how that happens every time. So that's that. And then the third sort of flavor is when you multiply something like this by something like this. And I don't mean to insult your intelligence by asking you this question, but what do you notice about these two binomials? Yeah, they're basically built from the same pieces, aren't they? There's a 5x and a 2 and a 5x and a 2. The difference is, and this is important, is that one of them has a plus and one of them has a minus. And the order of that doesn't matter. But what happens is pretty spectacularly cool. So here we go. What's 5x times 5x? Mm-hmm. And then what is 5x all the way across times negative 2? Right. And then 2 times 5x. So plus 10x. Remember to always insert a plus or a minus sign. And then what is 2 times negative 2? Right. And what's my final answer going to be? 25x. Nice job. And in the same way, last time, that last problem, that we noticed that the two terms in the middle were exact copies of each other, they will always be opposites in a case like this. So when you see a problem that's built from the same pieces, but one has a plus and one has a minus, these two terms in the center will always cancel each other out, always. And so they just go away and we're left with that nice short quadratic binomial for an answer. So I have a worksheet for you today. You're just going to practice this skill over and over and over and over again. We want to be really, really good at this so that when we factor starting very soon, maybe tomorrow, then we understand when we go backwards, like why the things that we're doing are happening. You can't be good at factoring until you're really, really good at multiplying. That's kind of the long and short of it. So any questions about that? All right, short and sweet. Let's see.